So here we are, premise 2. We're having a little trouble. Premise 2 is like, what are we going to do with this? Because I need evidence for it. So here's premise 2. The universe began to exist. Here's your buddy. You're nuts. Here's your evidence, right? And so remember, this premise is not a deductive argument. This is inductive, where you need evidence to decide on the most reasonable explanation for this premise. So we come in here, we have 11 facts about the universe that all scientists agree with. So we have collective unanimous agreement in the scientific community, and all of them point to a universe that began to exist. All of these. You have Newtonian physics and the laws of motion, which are another way of looking at Thomas Aquinas. When he put his together, the prime mover, he talked about motion. And what that means is, hey, objects at risk stay at risk. And any object you find that's in motion couldn't have gotten into motion unless something put it into motion. The second one is, hey, there has to be an external force on any object if it accelerates or decelerates. If there has to be. Objects on their own don't accelerate or decelerate. And then there's an equal and opposite reaction or effect to a cause. So these are known laws. I use this all the time in bridge building. When you're designing joints, when you're picking I-beams, they all are based on Newtonian physics. The next one is this whole idea of general theory of relativity. When he discovered that the things in the universe are not all behaving the same. So an easy example to help you guys, have you ever driven down the highway, a car comes up next to you, and when it's going the exact same speed, it looks like it's not moving. Is it moving? That's general theory of relativity. If you are in the reference point of your car, and from your reference point you're looking at another object, that object is moving at exactly the same time, space, and distance as you, so it appears to not move. The minute one of you accelerates or slows down, you see the difference. That's what Einstein discovered. Space curves. He discovered that gravity isn't that simple. He sees that things are relative to one another. That's what the general relativity means. The minute he discovered things were relative, he knew the universe had a beginning. Because it couldn't be eternal. Does that make sense?
Yeah.
Do you know how your GPS works in your car? There's an atomic clock on a satellite up in orbit in space that's set at a perfect time. Your GPS is bouncing off the satellite. It goes on that clock. The position of where you are is relative to the clock. The clock's measuring from you, and it's calculating then your position and speed based on that atomic clock.
Does it need 2 points?
Yes. Yes, it's like sonar or radar where you have a receiver and a transmitter, right? So as you're driving along and it says Davis Street in 2 blocks or something, right? That's general theory of relativity. It's giving you your relative position from an atomic clock. And all that the thing, what do you call it again?
GPS.
Yeah, what do you call it? Navigation device. All it's doing is it's just putting maps in there, and it's using that atomic clock position on the map and moving you around. So it's very helpful, and it was one of the biggest discoveries that caused everyone to realize, I think we have a universe from nothing. I mean, a universe that began.
So expound a little on the atomic clock helps give a superposition of where something's at.
Yes, a datum point. Yeah, it's just like if I wanted to know the position, how would I tell the position of my Bible on this table? How would I tell it?
You use the whole table to describe where it's at.
I'd have to pick a reference point. So I would say, I'll pick this corner. So now I've set my datum. And then I'd say, what point am I picking on my Bible? I'll pick that edge. So I'd say, okay, it's X, Y, right? I get the dimensions. But if I don't have a datum point, I can't tell a position. Does that make sense? Mm-hmm. That's what general theory of relativity is. It happens around us all the time. So we've got that. Then we move into the first law of thermodynamics. This is really cool. This is what's going on when you buy a refrigerator or a stove. You ever see those yellow stickers? It's talking about efficiency. It's combining first and second laws of thermodynamics. Because what happens is you have a certain amount of work that a refrigerator can do when you turn it on, but it can't be perfect. It just has an efficiency rating. So it's converting one type of matter to another type in order to run. But the conversion doesn't use up the other type, it just converts it. And it will be lost as heat. That's why when you feel the back of a refrigerator or your air conditioning unit, that heat now we're into the second law.
Right, there's no such thing as cold.
Yeah, there isn't. So when I think of the first law, and you're thinking about nothing's converted or destroyed, an example is my car out in the parking lot has gas in it. All right, does it have energy?
Kinetic potential.
What's the second word?
Potential.
There's just the potential for energy happening and useful work, but there's no work going on. What do I need in order to get work to be done or energy to move from potential to kinetic for work to happen? What do I have to do? What happens when I start the car?
It uses the gas.
How?
Burned.
How?
The spark plug.
Spark plug. Spark plug, we have a fuel called gas that's combustible, but it's not just the combustion that creates work. It's enclosed in a system. So it's under pressure, because what happens is when you combust gas and it turns to vapor, now it's trapped. And because it's trapped, it can't go anywhere. The pressure goes up and it moves the pistons, blah, blah, blah. But you didn't destroy the gas. You converted it to a different form of energy. What's the form of energy it converted from? From potential liquid energy to what?
Kinetic.
And what kind of kinetic?
Gas.
Mechanical. You're turning a shaft now. So you got work that the car can do that's mechanical, that's based on the liquid that got converted from liquid to steam to create mechanical energy and move your car. That's the first law.
Is it like true that we don't have an actual definition of energy? We always have to like relate it to something
Exactly
like
right.
mechanical energy. Okay.
We can describe it, we can't
Yeah.
define it.
Okay.
Another good example to think of the first law is when you ever seen in like colonial New England, they'll have if there's a stream going by, they'll have to create electricity in that building, they'll have a shaft with a paddle wheel on it, and the paddle wheel, when the water goes by, it turns. Why are they doing that? What's the purpose?
They're capturing the motion of the current and taking it elsewhere.
They're taking the potential energy of the water that gets turned into kinetic by the force when it hits the paddle, that now goes into mechanical energy by rotating the wheel, that then has a diode at the end that turns it into electrical energy for use for electricity. That's the first law. You took the stream's potential and turned it into electrical. So it's not been destroyed or created, it's just converted. And they discovered there's never a case of creating matter or energy. It's always being converted into another form. And that's the coolest thing to me. That's how the world works.
Yeah, and even all those systems, they don't even perfectly capture all the energy. All those systems have an amount of energy that's just lost because we can't, like,
Now
one.
we're going to get into the second law.
Yeah.
Because it's really cool. The second law is literally when you sweat. What's happening when you sweat? You're releasing, you're not efficient, 100% efficient, right? The same thing happens when your car's running. You wouldn't dare touch the engine or touch the shaft of the car. Why? It's red hot. Why? It's lost energy. It dissipates. That's the second law. It's called entropy. Why? Does my back hurt after a while? And I need all kinds of vitamins and stuff like that as I get older. It's the second law, right? Everything is moving towards a state of disorder. Everything.